Okay, so now for the next part of the problem, we want to show that these two functions are linearly independent. If we have two solutions and they're independent, then they form a fundamental set of solutions. So the easiest way to show linear independence is to find the Wronskian. And the Wronskian, again, is a 2 by 2 determinant made of the original two functions and their first derivatives. And again, we want to show that this determinant is going to be non-zero. So for our problem, our Wronskian is going to have our top row made of our e to the 4t and t times e to the 4t. And then for our second row, it's going to be the derivatives of each. So that's 4 e to the 4t. And then from before, that's 4t plus 1 e to the 4t. And now when we calculate a determinant, it's very important to make sure that we follow the rules on doing so, which is going to be to multiply the forward diagonal, which is the product of these two things. So that's going to be 4t plus 1 times e to the 4t times the other e to the 4t. And then it always has a minus in it. And then it's minus the backwards product, which is going to be the 4t e to the 4t times the e to the 4t. And then if we actually multiply out this quantity, we're going to have a 4t plus 1 and then multiplying the two exponentials makes e to the 8t. Then we've got a 4t e to the 8t. And then multiplying out, we have a 4t e to the 8t plus an e to the 8t minus 4t e to the 8t. And we see quickly that these two 4t terms cancel out. So our Wronskian is equal to e to the 8 times t. And then if you think about exponential functions and the fact that they have a horizontal asymptote and that exponential functions can never equal 0, it can be easily shown that this is not equal to 0, and therefore we know that y1 and y2 are linearly independent. And that's how we work with exponentials. Pretty simple. The other variation you'll see is trig functions, and sometimes you have to use a trig identity to write something in terms of something else to make sure that we can solve those. But regardless, the Wronskian is always the easiest way to verify linear independence when you're dealing with differential equations.